Okay, let's start the chapter. In this chapter, we'll be talking about inventory management and why inventory management is important for in operation. Now, the learning objective, we will explain how inventory is used and why it costs. Analyze how the different inventory control system works, analyze the inventory using Pareto principles. Now, inventory, can be visualized as a stacks of money sitting on forklift or on the shelves or and in the truck and planes while in a transit. For many businesses, inventory is the largest asset on the balance sheet at any given time. Inventory can be difficult to convert back to the cash. It's a good idea to try to get your inventory down as far as possible. And the average cost of inventory in North America and United States, especially, is 30 to 35% of its value. So inventory costs 30 to 35% of a company value. Lowering it will lower the cost of operation. Now, in early chapters, what we did in chapter 9, we talk about the raw material and manufacturing plant inventories, which is the material requirement, which is chapter 9. In chapter 11, we will be talking warehouse inventories and retail store inventories, which is single period, fixed order, quantity, fixed time period. Best model for managing the inventory in the supply chain inventory. Now, in the inventory models, there is what you call a single period models used when we are making a one-time purchase of an item, like a big set of a machine. There is what you call a fixed order quantity models is used when we want to maintain an item in a stock and we when we restock, a certain number of units must be ordered. And there is a fixed time. The first one is a first or fixed order. This is a fixed time period, which is the item in order at certain interval of time. Every 3 months, every 1 year, every 6 months, we make an order. Now, a definition, inventory, the stock of any items or resources used in an organization. That include the raw materials, the finished product, the component part, the supplies, and working process. There are also manufacturing inventories, which is refers to items that all contribute to or become a part of a firm product. Then when we have inventory system, we want to know what's an inventory system is the set of policies and controls that monitor the level of the inventories. It determines what level should be maintained, when stock should be replenished, and how this large order should be. The purpose of inventory is to maintain the independence of the operation. You have things in the warehouse, so anytime you need, you can operate and maintain the independence. To meet the variation, the other purpose is to meet the variation in the product demand. So once you want to produce 100, the next day, suddenly you have to produce 500. To allow the flexibilities in the production schedule, and to provide a safeguard for a variation in a raw material delivery inventory. Plus to take advantage of economic purchase order size. The more you buy, the cheaper it is, and domain specific reason, anticipation in a transit, or have some kind of strategic plan for it. Now, when we're talking about inventory cost, it's what you call a holding or carrying cost. Cost for storage, handling, insurance, and so on. Defective product, maybe some of them. Then you have the setup or production change cost, cost for arranging specific equipment setup, and so on. Then you have the ordering cost, which is the cost of making an orders, cost of placing an order, and you have the shortage cost, which is cost of running out of in warehouse. So demand types, there is what you call independent demand, and there is what you call dependent demand. The independent demand is the demand for various items are unrelated to each other. For example, in a workstation, you may produce many parts that are not related, but meet some external demand required. They produce so many other things. In the dependent demand is the need, any one item is a direct result of the need of some other item. So you need tires for the car. This is dependent demand. Usually a higher level items of which it is a part of. Now, in the inventory system comparison, you have what you call a single period inventory model, and then you have a multi-period inventory model. In the single period inventory model is a one-time purchasing decision. Example, vendors selling a t-shirt at a football game. There is an event, you buy amount, and it seeks to balance the cost of the inventory over stocks and under stock. So you don't want to buy too many t-shirts, and you don't want to buy not enough t-shirts because it's an event base. And then you have what you call a multi-period inventory model, which is a fixed order quantity model. It's an event triggered, running out of the stock. Whenever you're running out of the stock, you order, or could be a fixed time period models, which is time triggered. So monthly sales call by sales representative. Every month you need to replenish your stocks. Now the single period inventory model consider the problem of deciding how many newspaper in a hotel lobby. Too few papers, and some customer will not be able to purchase a paper, and the profit associated with these potential sales are lost. Too many papers, and the price paid for the papers that were not sold during the day will be wasted or lowering profit. And you notice that sometimes you know that an expensive t-shirt sold at a very low price because there is a logo for certain event or certain team that they did not do well, and they overstock, over ordered, so they had to sell it really cheap. Now the single period model application, uh, overbooking of airline flights, ordering of clothing and other fashion items, one-time order for event, like the t-shirt for a concert. In the multi-period models, there was what you call a fixed order quantity models, also called the economic order quantity or EOQ, or the Q models, which is, it is an event trigger, as we said, football, uh, World Cup, I don't know, it's an event. And then you have what you call a fixed time period, which is also called a periodic system, periodic review system, fixed order interval system, and what you call a P model, because a periodic system. And it's a time trigger. So every 3 months, you check the warehouse and you buy the missing part or the amount is lowered. So in the comparison between both, the fixed order quantity is inventory remaining must be continual, always monitored. In the fixed time period, the counting takes a place only at the end of review period. In the if fixed order quantity, you have has a smaller average inventories, favors more expensive items. In the fixed time period, has a larger average inventories, favor less expensive items. In this one more, this one less. In the fixed order quantity, you have is more appropriate for important items. So we want to have the more important is there. In the fixed time period, is sufficient for the less important items. Uh, in the fixed order quantity, require more time to maintain, check the warehouse, but is usually more automated, and it's more expensive to implement because you're always checking. But in the fixed time period, require less time to maintain because every 3 months you can go and check, and it's less expensive to maintain because every 3 months you can go and check. So this is another way of the multi-period models. And what you have here is the features, which is order quantity constant, the same amount ordered at each time in the Q model. In the P model, which is a fixed time period model, is a varies each time order placed. When to place the order, when the inventory position drops to a pre-order level, that's in the Q model, but in the P model is when the review period arrives. In record keeping, each time with a draw or additional, you lose one, it's counted. And in the P model, counted only at the review every month or every 3 months period. The size of inventory here is a less than fixed time period model, but here is a larger than the Q models. And time to maintain higher due to the always keeping the record, and higher price types of items is usually for higher price critical or important items. So the process is like this. In the Q model or fixed order quantity system, the ideal state waiting for the demand, and the demand occurs unit withdraw from the inventories or back ordered, and then compute the inventory's position, which is position equal on hand what you have, plus on order minus back orders. And if the position is less or order point, then if it's yes, issue an order. If it's no, you go back and do this calculation again and again. In the fixed time period, is usually, the demand occurs unit withdraw from the inventories, has nothing to do with making an orders because it's a timing. So ideal state waiting for the demand, has a review time arrived. If it's that month of the year came in, then if it's yes, You compute the inventories, see the position, what you have in hand, plus orders minus the back orders that you done is done. Compute the order quantity and bring the inventory up to required level. Issue an orders. If it's no, you go back. You notice they are not affecting by the demand, is not driven by demand. Now, in the fixed order model quantity, the assumption is demand for the product is constant and uniform through the whole period. The lead time, time for ordering to receipt, is a constant. 1 week when it's reached to certain amount, 1 week before that, you make the order. The price per unit of the product, we assume it's constant. Inventory holding cost is based on the average inventories. And the order or the setup cost, we assume it's also constant. It has to be constant in order to go through these. And all demands for the product will be satisfied. So what they do, it is in the fixed order quantities, there is the quantity up to this level and start declining. Once it's reaching a certain time, they don't care how much is declining, reaching certain time. So if they reach at this time, they will make an order. And you know, when you make an order, take time. So they know the quantity will go down and then they order again. And when it reaches this time, they will make an order and separately and the quantity will go down. So then it comes in a warehouse. So always order Q quantity when the inventory reached to the order point, which is this one. And then inventory arrives after a lead time, so 1 week or something. Inventory is raised to the maximum level of the Q. And inventory is consumed at a constant rate with a new order placed when the order point is reached at, once again, it's a constant consumption. Once it's reached a certain level, you order, keeps going down and then fill it up. And it goes down a certain level and then it goes up again. But what do we want to do? We also want to establish a safety stock level. Safety stock level, amount of inventory carried in order, carried in addition to the expected demand. Safety stock can be determined based on many different criteria. A common approach is to simply keep a certain number of weeks of supplies, 2 weeks, 6 months, something like that. A better approach is to use the probabilities. In this time of the year, the chances happening like this, it's more consumption probabilities, and that time of the year or days, less consumption. And it's basically what it's done is assume that demand is normally distributed and assume we know mean and the standard of deviation to determine the probability. We plot a normal distribution for expected demand, and we note where the amount we have lies on the curve. So we have the standard and the deviation this way and this way, and we want to make it in a safe zone. But in the fixed time period model, is basically you might be facing sometimes the amount goes down, and that's when you do a deviation and calculation. Because sometimes you run out of the safety stock for certain consumptions. And that could be a dangerous, like in this case, because it takes time to do orders. So the time period are equal, but the ending inventories is varies. So every 3 months you check it and the time period is equal, you have some safety stock. But if you notice here, they did not do a good calculation for safety stock. This is when you're out of the stock, you're stock out. And reorder quantity varies depending upon the ending inventory. So notice here, if you do a calculation of inventories and you take the differences that you are back ordered and see. So that's what you call the P in the period models. Inventory control and supply management. Average inventory expected amount of the inventory over time. So you take an average of it. Inventory turn, number of time, inventory, how many time is inventory 10 pieces, how many time is turned a day or a year or whatever, a measure of how efficient inventory is used. Now, inventory models with a price break. Price varies with the order size. So you order 10, it's $5. You order 100, is $4, for example. And to define the lowest cost, calculate the order quantity of each price and see if the quantity is feasible. Now sort the price from the lowest to the highest and calculate the order quantity for each price, starting with the lowest until feasibility order found is found. There's a certain calculation you can do to find how much quantity you need to order today. If the first feasible order quantity is the lowest price, this is best. Otherwise, calculate the cost of the first feasible quantity and calculate the total cost of at each lower than the first feasible order. Keep in mind, when you're stocking, there is a price in the stock. There is a price in moving. There is a price if not consumed. So all these things you need to calculate that. But at this level, we don't do these things. So the inventory management is two parts. One, inventory accuracies refers to how well the inventory records agree with the physical count. If you have 100 and your physical count is really on the record is 100 and in the warehouse is only 50, that's bad, has to be really catching up. So inventory accuracy refers to how well the inventory records agree with the physical count. And the second part is cycle counting, which is a physical inventory taking technique in which inventory is counted on a frequent base rather than once or twice a year. So these are two things that first we have the accuracies in the warehouse, and then the right calculation is done how much we need to consume each month or each time period. And this is the end of it.